In these two problems, we're going to be solving linear equations. In the first one, we're going to solve a linear equation of one variable, and then in the second, we're going to solve a linear equation of two variables. So to start off the first one, whenever you're solving an equation with one variable, your goal is to get that variable on one side of the equation completely alone. So our first step is to move the smaller variable's coefficient to the other side. So the coefficient is the number in front of your variable. So in this case, there's a 5 in front of our x, and there's a 2 in front of this x. We want to move the 2 to the other side because it's smaller. While it doesn't matter which one you pick, in general, if you move the smaller one, you're less likely to deal with negative numbers, division by negative numbers, that is. So, the first thing we want to do is subtract this 2x from each side of the equation. Because this is a positive 2x, in order to remove it from this side of the equation, we have to subtract 2x. And when we do that, the 2x minus 2x will cancel out here, and then the 5x minus 2x will leave us with 3x. Then we still have this plus 3, and that is all equal to this negative 7 that we started with. From here, we now need to get the x alone, and the way that we handle that is to take care of any addition or subtraction. So because we're adding 3 to it, we have to subtract 3 from each side, just like we had to subtract that 2x from each side. And when we subtract this 3 from each side, the plus 3 and the minus 3 will cancel out, leaving us with 3x equals negative 7 minus 3 is negative 10. And now finally, to get our x alone, we will divide each side by the number that is in front of our x, which is 3, which leaves us with x equals negative 10 thirds. And that is the value that if you were to plug it in for x in each side of this original equation, you would get a solution. You would get one number equal to itself. Okay, now for this problem, we want to solve for y and then graph. Whenever you have one equation with two variables, you cannot solve for the two variables like we did here. You cannot get a number. But you can get one of them alone in terms of the other, and that's what we want to do here. We want to get this y alone, so the way that we do that is moving the x to the other side. So in order to move negative 6x, we're going to add 6x to cancel it out here. But because we did that, we also have to add 6x to the other side of the equation so that we're not changing it, which leaves us with 3y equals 6x plus 9. We cannot add the 9 and the 6x together because they are unlike terms. That x isn't attached to the 9, so they cannot be combined. Now from here, the y is nearly by itself, but we still have a 3 in front of it. And just like in the last problem, whenever you're multiplying a number to your variable, in order to get rid of that number, you divide each side of your equation by that number, which gives us y equals 6x plus 9 over 3, which is the same thing as 6x over 3 plus 9 over 3. Whenever you have addition or subtraction in the numerator or top of your fraction, you can split it up into two separate fractions over the same denominator. This only works if that addition or subtraction is in the top. It will not work if it's in the bottom. Okay, and now we did that because now 6x over 3 is the same thing as 2x, and 9 over 3 is the same thing as 3. So we were able to just simplify this. We now have y solved for, and it is in terms of x. So y equals 2x plus 3, and we now want to graph that. So this is going to be a very rough sketch of our graph. That's a little too rough. So with this, we're going to use graphing with slope-intercept form since our problem is already in slope-intercept form. And the way slope-intercept form works is you have y equals mx plus b. Notice in this case we have y equals 2x plus 3. So if we were to pick out m and b, that means m has to equal 2 in this case, and b has to equal 3. These numbers are important because b tells you your y value on this y-axis, meaning if we go up 3 points on our graph, we can place a point at y equals 3, and that represents this b value. It's also called the y-intercept, where the graph hits the y-axis. And now from here, this m is important because this is our slope. Your slope, in this case 2, tells you how much you go up versus left and right. So this 2 can be rewritten as 2 over 1. Any number is the same thing as itself over 1. So this is telling us for every 2 we go up, because it's positive, we will go to the right 1. So if we start at this y-intercept, if we go up 2 and to the right 1, we will get a new point on our graph. And if we go from here up 2 and to the right 1 again, we will get another point on our graph, which gives us a graph that looks like this when we connect the dots. And every point on this line represents a solution to this original problem that we started with of 3y minus 6x equals 9.